Okay, good to see everyone. Welcome to our Kubrick webinar, which is on the modern data scientist, a role evolved. So it's great to have everyone on this session. So what we're going to do is just to think of the different audiences and what people might want out of this webinar. You may be someone in the data industry, and you want to demystify perhaps what the data science role is and has been, and what evolution it's gone through over the last decade or so. Maybe you are a hiring manager and you want to get a better understanding of what the expectation should be of a data scientist, but also the supporting roles around a data science, as we will go through. But what we're going to look at is how the data science role has been forced to evolve, if you like, the survival of the fittest a little bit, and how that's been shaped and molded, as all types of adaptions are in when we look at this kind of scenario. What is it that has shaped the changes required of a data scientist? So first up, I just wanted to frame this around the context of a data scientist 11 years ago. Why am I picking 11? What's wrong with 10? Well, let's just hang this off of the famous quote in 2012 by Thomas Davenport and DJ Patil that was published by the Harvard Business Review. Everyone's heard of this, of the data science is the sexiest job of the 21st century. So what are some of those characteristics that were published in that review in 2012 of a data scientist? Well, if we go through, firstly, just pulled a few snippets out and we'll just sort of collect them together. Here we can see three roles of a data scientist as were published, and really these green ones, if you skim read them, they're talking about the exploratory data analytics, the nature of a data scientist to explore data and identify patterns. And there's probably no big shocks there, that is what a data scientist would be able to do, explore data. But next up, we can see two snippets here that really, these are quite interesting. They're talking about a data scientist bringing structure to data that was previously formless, and also then joining data down the bottom there, enriching data, combining together, integrating it, and even, you might be surprised, cleaning data. So that's what we've got in blue. What else is the role according to 2012's definition of a data scientist? Well, in yellow there, we can see really some very important stakeholder engagement skills, and how the data scientist would then deliver value back to the business. Very importantly, it's all about supporting those business stakeholders. Similarly then, how does the data scientist operate with those business stakeholders? In the purple blobs, we can see important communication skills, presentation skills, storytelling, and visualization. And then there's one more little red blob there. Against a data scientist's most basic universal skill is the ability to write code. So this could be summarized by this final point that we've got. Think of him or her as a hybrid data hacker, analyst, communicator, and trusted advisor. Well, I'm sure this is the type of person anyone would love on their team or even love to be. However, the reality of it is, considering what we now know about the complexity of data, the volume of data, and all of the other complications around business problems that data helps solve, surely this is asking for a unicorn. And unfortunately, unicorns don't exist. So this takes us to my next point, which is, again, I'm sure we've heard of this as well. Data is the new oil. But what was meant by that quote? It was published again a number of years later in The Economist, the world's most valuable resource. So was Clive Humby really talking about the value of data when he said data is the new oil? Well, no, actually. He was referring to the fact that, like oil, data in its raw state, unrefined, you can't do anything with it. If a data scientist was to work with unrefined data, then we have garbage in, garbage out. So this was actually a really important statement. And it aligns with two of those quotes that we've got up here. that referred to the importance of, and back in 2012, a data scientist supposedly was the person to integrate, enrich, cleanse, bring about data quality, logically data model, kind of do everything, right? So you got this unrefined data, make it useful, get results out of it. And therefore it now becomes like refined oil. So let's split the areas of evolution that we're going to quickly examine into 4 areas. We're going to look at the how emerging tech has emerged, how tech has emerged over the last 10 years. What influence has that had? And it is huge. If you cast our minds back over the last 10 years, the influence tech, for example, cloud, 10 years ago, cloud did exist, but we'll go into the details of it. But how many data scientists that might be on this call were at organizations that were cloud native? Probably none 10 years ago. So that's an example. We'll go through some significant and influential emerging tech. The supply pool. What was the supply pool like 11 years ago or 12 years ago versus now? How diverse was the talent pool that organizations had available to them for data science? And then under demand, which industries were hiring data science? Was it just niche industries versus now? We've got some nice stats that we can share about the prevalence of the data science role across different industries. What skills was expected of a data scientist, and what regs were in those industries that formed the need of data scientists or constrained what a data scientist should or shouldn't do. And then finally, the data volume then and now, and what type of data is dealt with. So that's some of these we'll skip through quicker than others. But under the volume and type, here we go. 2012, the amount of data that existed in the enterprise versus what we see now in 2023, we can measure it in zettabytes. So what is a zettabyte? Well, a zettabyte, think of it in terms of terabytes, that maybe that is more familiar. So 1024 gig. Wikipedia very helpfully tells us that if each terabyte in a zettabyte was a kilometer, it would be equivalent to 1,300 round trips to the moon and back. Well, it's a round trip, right? So 768,800 kilometers. This is a zettabyte. So sure enough to say, pretty huge. And so we are now dealing with 120 zettabytes of data. So what impact does the hugeness of that data, the great volume of data, have now that a data scientist, if they were to have the skills that were expected of them in 2012 and continue to now, what would they have? How would that impact them? Well, if we have that amount of data, then a data scientist obviously needs computational power to be able to produce results and analyze this sort of data. So they must have in mind cloud sustainability and also FinOps, which means the cost of cloud compute needs to be scalable and reasonable. And we must also think of the environment and ESG consequences and sustainability of wise usage of cloud. Is that the role of a data scientist? I would argue against, but that's an example of evolution. But it's also the type of data. And, we often hear about the volume of unstructured data versus structured. And so we can see that right now it represents 80 to 90% of enterprise data is unstructured. And that requires a different approach to handling for a data scientist. How about the talent and diversity? How has that shaped and evolved? Well, back in 2012, there were 0 universities offering data science as a bachelor's or master's degree. However, now in the UK, we've got 56 out of 166 universities who are offering data science bachelor degrees, and that is spread across 142 different courses. So we have some great evolution for the better in terms of availability of supply. However, ultra sad news is that for those students who are hugely excited about Gen AI, the gender divide is now getting worse than it ever has been, as if it couldn't have got any worse. It is worsening, which is why Kubrick have such a focus on increasing diversity in our roles. If we were to just hire from comp science degrees only, then we would not be additive to solving the problem of diversity, which is why Kubrick hires from particularly psychologists and social science, is a great background for people coming into data science. How about the tech component? So understanding what has happened in emerging tech. Well, probably you may all be familiar with, or possibly you may all be familiar with, the Gartner hype cycle for emerging tech. They release it every year. It's one of hundreds, if not over 1,000 different hype cycles that they produce at Gartner at various different niche levels. But they do produce one for emerging tech. And so just a couple of points to understand about this. A technology makes its way from left to right from an innovation trigger, and it gradually creeps up the innovation trigger. And this is because of the increased focus it is being given by press and media, until it's building up the hype until it actually reaches this peak on the expectations y-axis of inflated expectations. What does that mean? Well, it means that it's unrealistic. The expectations that are put on the technology itself in terms of what problems it's going to solve for us all are unrealistic. So inflated expectations, but nothing wrong with that. I suppose we could say is great that people are getting on board with backing this particular technology, but inevitably there is going to be some disappointment because they are unrealistic expectations. And so over on the right, in the middle of this expectation level, we have reality, which is the plateau of productivity on the right. And we go through various stages before, of intense disillusionment through to the slope of enlightenment. So what we want to do is shorten this gap between unrealistic expectations to actually then, I now know this technology is actually really awesome at solving these kind of problems, and it's great in this scenario. Let's be realistic about it, and we now know what we can do. So the question might be, how do we shorten that gap? Probably everyone knows right now what is at the peak of inflated expectation is generative AI. And we do tend to hear quite often organizations coming to us and saying that, they want to implement large language models, they want to implement generative AI. And the question that we'll come back with is, this is fantastic. What business problem are you trying to solve? What would you like to get out of that? And then often this is where it all gets a bit fuzzy. The business maybe doesn't know. And that's because that's what the definition is of the peak of inflated expectation. Surely it's going to solve all our problems, or some problems we don't know quite what or how. So how do we shorten this gap? It's by getting real. It's by delivering, working on proof of concepts. It's by exploring. It's by actually seeing what is the capability of this technology. It costs time, it costs money, and it costs skills. And through that time, money, and skills, you innovate and you explore. Again, where Kubrick can come in with our accelerators program. So as the items are plotted throughout this hype cycle, the different key up the top there is that Gartner will provide us an expectation as to whether this will move to the plateau, which is where we want everything to get to within 2 to 5 years, less than 2 years, or 5 to 10, and so on, or more than 10. So what have we done? Well, we've crunched some numbers. We've been through every single hype cycle in this category between all 13, do the maths, between 2011 and 2023. And we've picked out some of the many, you can see there, zoom in, you can see many different items plotted over those 13 years. We've categorized them, and we've got some significant things to talk about. So first of all, governance. Remember, in the 2012 definition of a data scientist, one of those points was they should be cleaning the data and integrating it and organizing it and making it trustworthy. Well, is that realistic? Have a look down the bottom left, a quote again from Gartner, my favorite source. AI flooded into organizations and is common. Governance is hard. Future success depends on it. So for such an important thing to have quality data, AI safety, governance, should this fall on a unicorn that is also busy doing all the other things that a data scientist should do? Well, no, obviously. Data governance is a role of its own. It's evolved out of the role of a single person. So we've got differential privacy, which is identifying risk of exposure of individuals through data about that individual and how to control that privacy. And another one down there, AI TRISM, which is an acronym for Trust, Risk and Security Management. Well, that reached the peak of inflated expectations this year also, along with generative AI. Let's skip over to AI on the right-hand side. And by the way, any questions, just type away and we can answer these later on in shortly. AI, well, this had a huge presence. It's not new. AI neural networks, in fact, were demonstrated in 1957. Why has it taken so long to suddenly reach the peak of inflated expectations? We'll talk about that in a minute. So a few entries that have appeared through the Gartner hype cycle there that are certainly not new. Natural language question and answering. Well, basically, this is what a chatbot is, isn't it? But this has been in the hype cycle since approximately, sorry, in fact, it was 2010. This appeared in the hype cycle. Cloud sustainability. Well, we talked about the mass increase of the amount of data. A data scientist, it should not be responsible solely for the efficiency, not only of the sustainable use of cloud compute, but also the financial cost of cloud compute. So we pull this out to a separate role. Cloud engineering is often the right role, and also MLOps in the specific case of AI and data science to be responsible for all of the operational aspects on cloud deployed models. Something else that's been incredibly exciting over the very short recent time is low code. We've heard this talked about a lot. So citizen data science, you can see, was in the 2015 hype cycle on the left there highlighted, and also similarly advanced analytics with self-service delivery. So what does this mean? Well, although in the 2012 definition, our data scientist is very close, rightly so, to the stakeholders, very clearly understanding the business problems. As complexity has evolved over the years of business problems that we look to solve with data, maybe it's better to, in some, not replace, but augment by leveraging the domain experts, not the technology experts. But the problem is, how do the domain experts solve business problems with tech? Well, via low code. There are now multiple products, plenty of products on the market, but for example, Kubrick partners with Prophecy, with Alteryx, with Data IQ. These are some great products that allow complex access to AI and data science technology, but into the hands of citizen data scientists, therefore, who are not wanting to write code. So what was life like? Let's look at the whole context for a data scientist in 2012 when their role was declared sexy. We obviously we can't plot everything, but we can see cloud existed. Amazon, GCP, Azure, we've got the legacy old vintage logos down there. That existed, but just because it existed, Azure launched in 2010, doesn't mean 2 years later businesses had implemented it, because they hadn't. Largely speaking, organizations were on-prem, gradually moving to hybrid. You know, it was only in recent years, say 4 or 5 years back, that we had cloud move into the plateau of productivity. They certainly did have like pandas and scikit-learn and great tools for a data scientist's disposal, but handling big data and serializing big data and having optimal read-write from cloud data lakes just wasn't around. So it was more of an analytics role without the need for engineering on big data. Big data also didn't reach the peak of inflated expectation until post 2012. So by applying the dates when these products were released, which is what we saw, versus the number of years later that it actually took them to reach hype, we can see that there was very little of this technology actually available in 2012 that we now, perhaps you would say, take for granted. That's what these arrows are showing. So that's our quick roundup on how tech has evolved. Just a couple of minutes on the last 2 points here. What about industry? Well, this is taken from IT Jobs Watch in the UK, where we can see how different industries are apportioned out across data science roles. So 29.6% of data science roles are in finance and insurance, according to IT Jobs Watch. And then I've highlighted some of the real primary industries here. It's no surprise to us here at Kubrick and my experience that in manufacturing and healthcare and life sciences are huge in data science. Perhaps this is due to the immense complexity of these organizations and the supply chains that they're dealing with, and which also explains why those organizations are also the most prevalent in cyber attacks, because they are highly complex. So that benefits data science as well as these other areas. So whereas at the bottom end of the scale here, you can see retail and broadcasting, very low utilization of or demand for data science roles, relatively speaking. So some interesting stats to look at. So really then, if there are no unicorns, sorry to break the news to anyone, then how can we successfully achieve a team which collectively will make a unicorn if you zoom out? So this doesn't apply to all organizations. They may not organize their AI teams in this way, but theoretically, we could say that data scientists are very close to the business. That's not theory, that's fact. Right? We know the data scientists work super close to the business stakeholders. However, they are no longer responsible for engineering, organizing the big data that is in front of them. We have data engineers for that purpose, and the data engineer will work with the data science as well as the ML engineers. What is the difference between a data scientist and an ML engineer? We'll come to that in a moment on my final slide, but both are supported by the data governance. Remember, Gartner said how difficult data governance is, yet how crucial it is. This should not fall on the data scientists. This is separated out. And then the productionization of our machine learning models, ML ops. I have separated them out between an ML engineer and ML ops, although these come under the same umbrella of productionizing. But an ML engineer is really responsible for taking the models of a data scientist and taking them to production. So an ML engineer will be an exceptionally good programmer and have great knowledge on cloud and cloud infrastructure technologies such as Kubernetes to be able to make that succeed. Whereas an ML ops engineer, if we were to separate them out, which sometimes they're not, is all about the model maintenance and the life cycle of a model, which is why then that has a feedback loop coming back to the data scientist, because models do not persist forever. They're going to drift and they're going to need maintenance and change and recalibrated and rebuilt. And then all of this is supported on the right-hand side by our cloud engineers, who are the experts in repeatable, robust delivery and reliability of anything deployed, any product deployed to cloud, AI and machine learning models being an example of that. So if you need, like I say, not all organizations do split out a data scientist from a machine learning engineer, but here we can see some of the skills of a data scientist. So this is from scraping 20,000 current job listings. And by current, I mean, where are we? October 2023. And the proportion of those skills decreasing there over to the right. I've cut it off because it's a wide chart, but let's just compare the highlighted yellow versus the highlighted blue. You can see analytical skills such as SQL, R, stats, and the visualization there, even in Tableau, but pandas, regression, forecasting. This is all to the left. These are core skills of a data scientist. Analytics, no surprise, what we expect. But because of the volume of data, they're going to need AWS and Azure and Spark skills to be able to even process such large volumes. So there we have the core skills of a data scientist, largely analytics on the left, but decreasingly so some engineering and ops skills as well. Let's compare that to a machine learning engineer. You can see it's different. A machine learning engineer has more blue to the left. So TensorFlow, Docker, CI/CD, these are all core skills for productionizing. So they are exceptional coders. You can see Python super high again, but they must be able to deploy, and C and C++, they must be able to deploy their models to the cloud. So MLOps is quite close up there on the left as well. And then the more analytical capabilities, which a machine learning engineer must have. After all, they are deploying machine learning models and AI models, but they're less critical to successfully delivering as a machine learning engineer than the blue engineering skills. So your pandas, scikit-learn, NumPy, regression, classification, these are knowledge they must have, but secondary. It's difficult, it's still critical, but secondary to the important engineering skills. So they are separate. The cloud has evolved. The cloud has even been born since 2012, really adopted by clients. And with that, the complexity of it. And a machine learning engineer understands those technologies. So let's wrap up. What's our takeaway points? You can't overinvest in workshops on AI and data hype. This is crucial. If you want to close that gap from the peak of inflated expectations to the plateau of productivity in next-gen tech, and sorry, in generative AI, particularly, you got to do workshops, embrace the hype, push out the hype within your organization. Kubrick, we offer accelerators, which are our free POCs. Leverage small data and synthetic data for those POCs. Anything that gets hackathons and delivery of these proofs of values out quickly and broad is going to be key. Governance, critical. Govern your AI via centralized teams, and leverage low code. We want to be able to commoditize AI out to the business. So whether it be your Prophecy, Alteryx, your Data IQ, and other products like that, this is really important. And the more you hear about prompt engineering, get that out as well. This is a skill like everyone should have skills in Excel. Everyone must very soon have skills in prompting. Speed up the time to productivity by Gen AI by investing in talent. As I said, Gartner said the 3 things that will get this to productivity is time, that's inevitable, investing in skills, talent, and exploration of this technology. And then finally, your data scientists are not unicorns. Don't overwhelm them. Instead, diversify the skills out to a team, but make sure those teams are diverse at the same time. Thanks everyone for joining the webinar. I'll sign off. Cheers.